Alright everyone, as you all know, today is the first day of presentations of your final projects. Each of you has chosen a scientist to research, and you will present their major contribution to the field of evolutionary biology to the class. Today's presentations all have one thing in common. They discuss remarkable discoveries by female scientists. Woman and science are two words that definitely don't belong in the same sentence. Yeah, just like female and doctor. Female scientists have made incredible discoveries that have helped shape our understanding of evolution. Now, of course, we are familiar with and have deep respect for the incredible discoveries made by male scientists, but today I would like us all to shift our focus and acknowledge the women who are so often ignored. Since Darwin's time, the leaders of the field of evolutionary biology have changed immensely. The once male-dominated field is slowly but surely becoming more balanced to include female scientists as well. Let us begin by listening to Megan's presentation about Mary Anning. Hi everyone! The scientist I chose to talk about is Mary Anning because I think she's really cool. Mary Anning was an English fossil collector who discovered and excavated many fossils in the coastal region of Lyme Regis, southwest England. Mary Anning lived during the 19th century, at a time when women were prevented from having formal scientific education because of the belief that women's intellectual abilities were inferior to men's. Because of this, Mary Anning had no formal scientific training and taught herself everything she knew as a fossil expert. She was from a poor family, and to make ends meet, she and her family relied on the income they earned from selling fossils such as hominoids, belemnoids, invertebrates, and large vertebrates to collectors and scholars. At age 12, Mary excavated the first ichthyosaurus fossil. Years later, she uncovered her most famous discovery, the first plesiosaurus fossil. Her discoveries challenged the way scientists at the time thought about the natural world. They provided evidence of extinction that contributed to Darwin's development of the theory of evolution. Additionally, her work helped establish the field of paleontology, which is a crucial component in studying evolution. Her work earned her a good reputation amongst other paleontologists and scholars, who were primarily wealthy men. But despite these groundbreaking discoveries, she was rarely given credit for her findings. Her discoveries were often published in prestigious journals, with credit attributed to the collectors who had purchased her fossils. As a female scientist, Mary Anning was not allowed to join the Geological Society of London, and didn't begin to receive the recognition she deserved for her incredible discoveries until after her death. Excellent work! Did you hear that? She discovered dinosaur fossils. Isn't that kind of cool? Yeah, it is. I hope you were all paying attention to the important points Megan brought up in her presentation. Evolutionary biology emerged at a time when women were largely excluded from the scientific community and were not allowed to contribute to scientific research. Mary Anning not receiving credit for her work demonstrates the pattern that traditionally, women's achievements in STEM are under-recognized. Now, let's move on to our next presentation. Hi everyone! I chose to do my project on Barbara McClintock. Barbara McClintock was an American scientist who spent her entire career analyzing the chromosomes of corn. When observing kennel color changes, she noted that color patterns change rapidly between successive generations. Various microscopy and staining techniques allowed her to analyze individual chromosomes in the corn, which led her to isolate genes that were responsible for color pigment expression. She called these genes controlling elements and determined that they could change positions along chromosomes, thereby changing expression of neighboring genes and creating mutations in pigmentation. The movement of genes along or between chromosomes is called genetic transposition, and these genes are often referred to as transposons or jumping genes. The discovery that genetic material is not stationary is very important to evolution, as transposons can cause small and large changes, specifically by altering genotypes and phenotypes by creating mutations. In 1944, she was elected as the president of the Genetic Society of America, and in 1983, she won a Nobel Prize for Physiology or Medicine. She was the first woman to win this prize unshared. Isn't that awesome? This is even more interesting because Barbara McClintock almost didn't even go to college. Her mother was worried that pursuing a higher education would ruin her chances of finding a husband, and dismissed her plans of attending university. But thankfully, Barbara's father didn't let this happen, and she went on to study at Cornell University, where her research began. Fantastic! Great job! I didn't know a woman discovered jumping genes. Me either. That was an excellent presentation, and it was great to hear all of Barbara McClintock's wonderful achievements. Sadly, many girls are discouraged from pursuing STEM careers from early ages, and many women in STEM face obstacles in their careers, including facing harassment and discrimination. Only 33% of STEM graduate researchers are female, and female researchers make up only 12% of members of national science academies. In the fields of ecology and evolution, women are underrepresented as first and senior authors, despite female authorships being submitted for review at almost the same rate as male authorships. Anyways, let's move on to our final presentation, and we'll discuss more about gender bias afterwards. For this project, I chose to talk about my favorite scientist, Tomoko Ohta. She is a Japanese scientist who began her research career in 1967 at the National Institute of Genetics in Japan, where famous scientist Moto Kimura was head of her research team. Tomoko Ohta developed the nearly neutral theory of molecular evolution, which is an expansion of Kimura's neutral theory of evolution. Ohta's theory emphasizes the significance of slightly deleterious mutations in populations, while Kimura's emphasizes the significance of neutral mutations. Hence, Ohta's theory is nearly neutral, because it states that slightly deleterious mutations, rather than neutral mutations, can be fixed in a population due to drift and weak selection. Tomoko Ohta was among the first generation of women in Japan allowed to go to university. She has stated that Kimura was a typical Japanese man of his time, who regarded women's scientific activities as insignificant, and she had to convince him to let her continue to do research with their lab. Tomoko Ohta is my role model. Seeing someone like me accomplish great things despite facing obstacles of gender bias during her career makes me feel like if I persevere, I can do great things too. That presentation brought up issues of gender bias in STEM. Gender bias in the academic environment has many social and individual causes. Gender bias has been described in research, where both men and women overestimate male competence and underestimate female competence. Additionally, gender bias often results in male scientists choosing to support, mentor, and work with other male scientists rather than female scientists, resulting in less female involvement and competitiveness in academic settings. Do you think those things we said were kinda uncalled for? Yeah, I do. Well, now that I think about it, they were cheap jokes and not funny. I agree. Women in science deserve the same opportunities, visibility, and celebration as men in science. Having little female representation in STEM results in less role models for young female scientists to look up to, leading to less women interested in and comfortable with pursuing careers in STEM. All scientists and academic environments must work towards finding solutions to gender bias by providing equal opportunities and affirmative measures for everyone in STEM. Great job, everyone. Class is dismissed.